This is a video presentation of Chapter 4, Section 2 in the 7th grade textbook entitled Rates. Our objective here is to find and compare unit rates such as average speed and unit price. So what is a rate? A rate is a ratio that compares two quantities measured in different units. So if you remember in the last section we were talking about ratios. Since a rate is a type of ratio, this is the logical next step for us here. Again, a rate is a ratio that compares two quantities measured in different units. What we'll spend a lot of time talking about in this section is a specific type of rate called a unit rate. A unit rate is a rate whose denominator is 1 when it is written as a fraction. So they're saying you're going to write that guy as a fraction and reduce it somehow so that the bottom number becomes a 1. That's what a unit rate is. It's a comparison to the number 1. For instance, in the examples we were talking about the other day, when we were figuring out how many cough drops were in an ounce in the notes for 4-1, that really would have been a unit rate because we were figuring out how many cough drops were in 1 ounce. That's what makes it a unit rate. Alright, so let's go ahead and look at number 1 here. Part A says a Ferris wheel revolves 35 times in 105 minutes. How many minutes does one revolution take? So, since they're asking us about how many minutes one revolution takes, that means they want the bottom number to become a 1, which means revolutions is going to have to go in the bottom. Again, that's what this section is mainly about. It's about unit rates, making the bottom number become 1. So when they're asking me when they're talking about one revolution, that's obviously what they want to go in the bottom. So even though the question says 35 times or 35 revolutions first, we know that's going to go in the bottom. So the fraction is going to represent 105 minutes for 35 revolutions. And then since we're trying to make that bottom number become a 1, we're going to divide by whatever the bottom number is. In this case, 35. So I'm going to divide both the numerator and the denominator by 35, which is what you can see happening right here. 105 divided by 35 is 3, and of course we know the bottom is going to go to 1, so I don't have to think too hard about that, which means it's taking 3 minutes for every revolution, or the Ferris wheel takes 3 minutes for one revolution. This right here, 3 minutes for one revolution, that is a unit rate. So you just figured out a unit rate in your first question. In the B question, it says Sue walks 6 yards and passes 24 security lights set along the sidewalk. How many security lights does she pass in 1 yard? So since they're asking me about 1 yard, we know the yards is what they want to put in the denominator of this fraction. The top then is going to be the other thing, which is the 24 security lights. So we're going to set up our fraction with 24 lights over 6 yards. And again, since the question is asking me to figure out how many lights are in 1 yard, I'm going to make the bottom number go down to a 1 here, which is what you can see happening. Well, since this is 6 in the bottom, I'm going to divide out 6. So I'm dividing both the numerator and denominator by 6. 24 lights divided by 6 works out to be 4 lights for every yard. So Sue is walking past 4 security lights in 1 yard. Alright, let's go ahead and take a look at number 2. Danielle is cycling 68 miles as a fundraising commitment. She wants to complete her ride in 4 hours. What should be her average speed in miles per hour? So, the question is saying miles per hour. And notice the emphasis there is in per hour, or per 1 hour. So that's what we want to stick in the bottom here. Miles is going to go in the top, it said first. So 68 miles in 4 hours. Well, if we're trying to get this down to 1 hour, that means I want the bottom number to become a 1. So I'm going to take whatever the bottom is and divide by it. So that's why you can see they're dividing by 4 here in both the numerator and denominator. To make this go down to 1, you have to divide by itself. And of course, when we're reducing a fraction, we do the same thing to both the numerator and the denominator. 68 divided by 4 is 17. 4 divided by 4 is 1. And we find out that her average speed is 17 miles an hour when she's cycling. Now, number 3 is a lot like that cough drop question we saw in 4-1. The difference is now they're really going to be talking about the price as opposed to the amount we just get per ounce. They're going to be asking me which one is the better buy, so we're going to be looking for whatever is cheaper, not necessarily which one am I getting the most for. When we did those cough drop questions, we were trying to figure out which one I was actually getting more for. Now I'm actually going to be looking for the smaller number because the smaller number is going to be what I'm paying less for. So, number 3 says a 12-ounce sports drink costs 99 cents and a 16-ounce drink costs $1.19. Which size is the better buy? So as you can see, they're telling us the setup there in that first line of print there, which says to divide the cost by the number of ounces to find the unit price of each size. So you're figuring out how much you're spending, in this case, per ounce. Okay, so that means that it's per ounce or per 1 ounce. That means they want you to make the ounces go to 1. So since the ounces are what's going to 1, and we know in a unit rate the bottom number goes to 1, the ounces has to go in the denominator. So with the 12-ounce drink, we're paying 99 cents for 12 ounces. With the 16-ounce drink, we're paying $1.19 for 16 ounces. And that's where those two fractions came from. Again, we're trying to make the bottom number go to a 1. So I'm dividing both the numerator and denominator by whatever the denominator is. So here, since I'm buying a 12-ounce drink, I'm dividing both the numerator and denominator by 12. Here, since I'm buying a 16-ounce drink, I'm dividing both the numerator and denominator by 16. Well, in the bottom, on either fraction, that's just going to ounces, or 1 ounce. So that's not going to be any different on either side. What is going to be different are the numerators. When I take the 99 cents and divide it by 12, I find out that I'm paying just over 8 cents an ounce. When I take the $1.19 and divide it by 16, I found out I'm paying almost 7.5 cents an ounce, just a little bit less than that. So this is just over 8 cents an ounce. This is about 7.5 cents an ounce. Well, obviously this one here is cheaper. And since that guy there is cheaper, that means the 16-ounce drink is going to end up being the best buy. Alright, so let's go ahead and wrap this up by looking at the check it out examples here. Number 1 is asking me to find the rate. It says a car gets 189 miles with 9 gallons of gas. How many miles does the car get in 1 gallon of gas? So my fraction is going to compare 189 miles to 9 gallons. Since the question is saying it's asking about 1 gallon of gas, we know that gallons of gas is going to have to go in the denominator, because remember, this is all about making that bottom number become a 1. And since they're asking me to make gallons a 1, that's what has to go in the denominator, the bottom. So it's 189 miles for 9 gallons. And then we're going to reduce the fraction so that the bottom number becomes a 1. So since the bottom number is 9 here, I'm going to divide both the numerator and denominator by 9. When I take 189 and divide it by 9, I end up with 21, as in 21, in this case, miles per gallon. So it's 21 over 1, or I'm getting 21 miles per each gallon of gas. Number 2, Danielle is walking 18 miles for charity. She wants to complete her walk in 3 hours. What should be her average speed in miles per hour? So they're asking about miles per hour, or miles per 1 hour. So not only does that statement give the order, but since they're saying per hour, per 1 hour, we know that that's what's going to have to go in the denominator. Again, the denominator is always what you're going to make go down to 1 here. So we got 18 miles in 3 hours. And again, since I want to make this bottom number go to a 1, I'm dividing by whatever the bottom number is, which in this case is 3. And of course, we do the same thing to both the numerator and denominator here. So when I do that, I end up with 6 over 1. Remember, the top represents miles, this represents hours, so it's 6 miles per hour. And we'll conclude by looking at number 3 here, which says a 28-ounce box of cereal is $2.99 and a 32-ounce box of cereal is $3.19. which size is the better buy? So the better buy again is whichever is cheaper. All right, so we're looking for the smallest value in terms of dollars. All right, again, our unit rate here is going to represent what we're spending per 1 ounce of cereal. So since I'm asking you what we're spending per 1 ounce of cereal, that means ounces is going to go in the denominator, because the idea here is to make the bottom number go to a 1. So when we look at the 28-ounce box, we're spending $2.99 for 28 ounces. When we look at the larger box, we're spending $3.19 for 32 ounces. Since the bottom number here is 28, I'm going to divide both the numerator and denominator by 28. Over here on the right side, since the bottom number is 32, I'm going to divide both the numerator and denominator by 32. So when we come back to the small package here, I find out that when I take $2.99 and divide it by 28, I'm spending about 10.5 cents per 1 ounce. Again, the bottom number is always going to go to 1, so we don't really have to think too hard about that. When I buy the large box at $3.19 divided by the 32, find out that I'm spending just under 10 cents per ounce. So this is a little more than 10 cents, this is a little less than 10 cents. Since I'm asking you which one is the better buy, this one is the better buy because it's cheaper, so the 32-ounce package ends up being the better buy.